All right, Mujari again on this particular channel. Of course, you know how we used to do it back to back, dropping short videos on some aspect of chemistry. And we're not just analyzing the questions. We are trying to look at why is the answer like that. So we're not jumping to the question as it were. Why is the answer like that? Now, some people used to say chemistry is difficult. Now, I know they like to hear that thing. So I've devised a means to make it very, very easy for you that if you get to follow this my series of lecture with Musjaru, you get to see how beautiful chemistry can be. And of course, what you have to do, the only thing you have to do is subscribe and of course share with your friend. In all they have to do, subscribe and share with your friend. Now, as you watch the video, make sure you share it. If you have subscribed already, do well to please share it. Thank you. Now let's go back to the question. I have a lot of questions. There is on fire today. I have a lot of questions to analyze, but I think I have 3 questions to analyze. So the video might be longer than usual, but I'll try and cut it very, very short so that you get the information. Now look at the question. They said the following are decomposable triazonitrates for except, let's analyze. They said the following, that means all of them here are triazocarbonate 4 rather. The following are triazocarbonate 4 except, that means all of them are triazocarbonate 4 and all of them are decomposable on heating. Except they say which one of them is not decomposable on heating. That means they are trying to say that which one of them is what is stable on heating. That means it will not decompose, it's stable on heating. So we have some salts that are unstable, and those salts that are unstable to heat are known as what? As labile salts. That means to say, if I heat a particular triazocarbonate 4, listen up. If I heat a particular triazocarbonate 4, all of them here will decompose on heating. Now, which one of them will not decompose on heating? So those salts that will not decompose on heating, those salts are said to be what? Are said to be stable. Now, indirectly, they're trying to ask us which of them is what? Is stable, because all of them are decomposable. Now, look at what I'm trying to bring out here very fast. Let me break it down. Take your breath, take your deep breath. Let's take it down. Now, don't rush. We said we have the following are decomposable triazocarbonate 4. Now, I said for a salt to be decomposable, that means it's unstable on heating. And those salts that are unstable on heating are what? Are labile salt. Now, let me quickly bring out something, because this question has been asked before in exam, both UTME exam, of course, JAM examination. They said, which of the following separation techniques or purification techniques can be used to do what? To separate salts, to separate labile salts. First of all, labile salts are salts that are unstable to heat. So to separate labile salts, I will use what? Crystallization. So crystallization is the technique that is used to separate labile salts. That is to say, salts that are unstable to heat from their solution. Now, what about salts that are stable to heat? For example, the one we use for house, talking about the what? Sodium chloride, the common salt that you use at home. Sodium chloride do not decompose on heating. Therefore, I cannot use crystallization to what? To separate it from solution. I can use what? Evaporation. So I will use evaporation to what? To dryness. So when I heat, the water evaporates. Now the salt will remain inside the crucible. Why? Because the salt is stable to heat. It does not decompose on heating. Now, so we have seen now that these 2 techniques are used to what? To obtain salt. But which of them? Crystallization is used to obtain labile salt. And you know what are labile salts? Now, while evaporation is used to obtain stable salt, those salts that do not decompose on what? Heating. Oh yeah, fast, we'll go back to our question. Now, this question, it is very, very simple. Now, you may think and say they hard. So let's check it out. They said the following are decomposable. That means all of them are decomposable, except, now, let's look at it. Now, let me bring it out for you. You know alkali metals. For you to know your answer, you know alkali metals. Now, we are talking about the likes of lithium, we have sodium, we have potassium, we have rubidium, we have cesium, and of course, we have the radioactive alkali metal, which is what? Francium. Now, triazocarbonate of alkali metals, listen up, triazocarbonate of alkali metals are what? Are stable to heat. That is to say, do not decompose on heating. You have gotten the picture now, and you can see, of course, if you want to do an elimination method, you can see that obviously you are seeing 2 answers in the options. But let me go further. That's why you don't need to watch the video halfway. You need to complete it so you to get to see the full gist. Now, but you have known this, that trioxocarbonate of alkali metals do not decompose on heating. That means they are stable to heat. Very good. Now, if you come back, you will notice that we have lithium trioxocarbonate and we have sodium trioxocarbonate. So these two are trioxocarbonate of alkali metals. So Mojaro, what are you saying now? Is there to answer in the option? No, it's only one answer. Now, this lithium here has a very small nucleus. As I've come, this lithium here has a very small nucleus, therefore is unstable to heat. So that means to say, if you want to just get it to your mind, that means trioxocarbonate formed from these guys are stable to heat, except what? Except the trioxocarbonate of what? Of lithium. That means lithium trioxocarbonate is decomposed on heating. That means if I break down, if lithium is heated, trioxocarbonate is heated, I'm going to get lithium oxide plus CO2. Now this is what I'm going to get. This will be my product. Now this is the only trioxocarbonate of alkali metals that decomposes on what? On heating. So obviously my answer here is what? Is D. So sodium trioxocarbonate do not decompose on heating. But I need to bring this to your knowledge, please. The trioxocarbonate of this guy, not the sodium bicarbonate. We are not looking at the sodium bicarbonate, just the trioxocarbonate. For example, NaHCO3. Please, this guy decomposes on heating. Please, this is sodium bicarbonate. So there's a question that usually comes out in the exam. So remember, we have Na2CO3. This is a normal salt. This is an acid salt. So one way of differentiating them in the laboratory is by heating. This one is stable to heat. This one is unstable to heat. So be very, very careful. Don't get it twisted. So you have seen why the answer is like that. Now, let me come back. If you look at the other option, let's leave lead out of it first. If you look at the other option, talking about magnesium trioxocarbonate, talking about calcium trioxocarbonate, you will notice that magnesium and calcium are what? Are elements in group 2. Now, this one is, they are elements in what? In group 1. Now remember, elements in group 2 are regarded as what? As alkaline what? Alkaline earth metals. Now you have to be very careful that the trioxocarbonate of alkaline earth metals decomposes on heating. That is to say, this guy CaCO3, you should know that this one are limestone. If you decompose, you form this guy quicklime, which is of course used to dry ammonia, it's a drying agent, plus what? Plus CO2, which is carbon dioxide. Now, likewise, if I'm having what? MgCO3, of course, it can decompose to form MgO plus what? Plus CO2. So the trioxocarbonate of alkali metals, without exceptions, decomposes on what? On heating. But the ease of decomposing is what is bringing the issue now. As you move from top to bottom, the ease of decomposition does what now? Decreases. That means the one that will easily decompose is this guy. So we're going to analyze these things as the class goes on. But just know that when it comes to trioxocarbonates, those trioxocarbonates of alkaline earth metals decompose on heating, but group 1 do not decompose on heating, except the only one that decomposes is what? Is that of what? Of lithium. Now, of course, lead trioxocarbonate, talking about lead trioxocarbonate now, this guy decomposes on what? On heating to not form what? Lead what? Lead oxide. Now, this ought to be PbCO3. Now, if this guy decomposes, we are having what? PbO plus what? Plus CO2. So, of course, this guy can decompose on heating. So, you have used an idea to have, you have seen a way now to understand this decomposition process and how we can separate salt that decomposes on what? On heating. Now, let me bring this out for us again. Now, they can get to ask us in this question. They can say, which of the following trioxocarbonate is soluble in water? First of all trioxocarbonates are insoluble in water, except there's only one, except those of what? Except those of sodium, potassium, and of course, wait for it, and of course, ammonium. Now, look at what I'm trying to say. All trioxocarbonate, 4 salts, are insoluble in water. But look at the only exception now. I've used one question now to key 2 bets. Now, you have known their decomposition ability, and of course, you are knowing now how soluble, how you can identify those ones that are soluble or not. So, all trioxocarbonate, 4 salts are what? Are insoluble, except those of what? Of this. That means all these 3 guys are what? Are soluble in water. They are the only ones that are what? Soluble. The rest trioxocarbonate four salts are what? Are insoluble in water. Now we have other issues to align with. Now let's look at another question. I think this question is going to be very, very easy, but let's look at the question very, very fast. Look at the question very, very fast. All right, now look another video, another question rather, for this lecture series. Now look at the one we're analyzing, another question we're analyzing today. The first one we analyzed just now was based on the trioxocarbonate four salts, and those ones are stable, those are not stable to heat, and now you can separate stable salts. So make sure that you watch the video, you take your time to analyze, and of course you have to jot things down if you have to. Of course you have to go back again to watch the video. Now look at this question. They said calculate the density of nitrogen gas at STP. Now, if you see a particular question, you don't rush. Go calm down. Then look calm. Analyze them. It's simple. Now, you don't see say STP there here, and you know what STP stands for. Standard temperature and pressure. If you like, go say Sandra today are precious now, you sabi. But na standard temperature and pressure. Now they can say calculate the density. Your brain will not be doing which formula to use. Now I have brought out some formulas on gas laws in my lecture series. So go down and check the videos that I've uploaded on gas laws and see the points and formulas you can bring from it. But quickly, let's go. Now, if you want to solve this question, because you have said density, almost Jaro. Now, they said density and talking about XTP. I know fully well that the equation of state, the ideal gas equation, is what? Is PV is equals to nRT. I want to prove out something. This is pressure, this is volume, this is number of moles, this is molar gas constant, and this is temperature. Now, remember that number of moles is mass over molar mass. Number of moles is equals to mass over molar mass. I can get to substitute this number of moles, this mass over molar mass, into this formula. And what will I have? I will now say PV is equals to what? NMRT. Now, what do I do next? I have to do what? Cross multiply. Therefore, PVN is equals to what? Is equals to MRT. Now, I have not done anything here that is so big. Now, look at it. Very, very easy. Now, open your eye. Now, I can divide both sides by V. Divide by V. Divide by V. V cancels V. Therefore, I can say Pn is equals to, remember now, mass over volume is density. DRT. Good. Now, I didn't want to bring the formula out. I know the formula that we're going to use, but I didn't want to bring it out straight. So I just want to show you how we take get the formula. So I mean, not good things say chemistry. Oh, chemistry don't hard. Oh, hey, how this formula take come? No, calm down. Look at it. This formula now can fall into this place because why we have density here. Now, all I have to do is that I'll make density subject of the formula. Back, now can come aside. So D is equals to what? Pm over RT. Slow and steady, they say, wins the race. It will not be all race. Oh yeah, let's go. STP. If you don't know what is standard temperature, of course, standard temperature, ST, is 273 Kelvin. Standard pressure in atmosphere is what? Is 1 atm. Now, it's in atmosphere we're going to be using because of our value of arrow that we're going to use. So D is equals to 1 times, of course, the nitrogen gas, you know, be small picking. Nitrogen gas is what? N2. So molar mass of nitrogen is what? Atomic mass is 14, therefore times 2, that'll give me what? 28. So will now be times 28 over 0.08205 times your temperature, which is 273. Now D is equals to 28 over. If you do this very well, you are going to, of course, you can plug this everything inside your calculator. So if you do it very well, you are going to be having what will you have when you plug it into your calculator? So you are going to be having 22.399. 22.399. Now if you divide it, what will you have? You now have what? 1.25 grams per what? Per liters. Okay? That's your answer. So, ladies and gentlemen, boys and girls, so this is how you can solve questions like this. So you see the way I brought it now. Now you have no equation of state. So sometimes, how do you know the formula to use is based on what they gave to you in your question. So what they gave to you, so they didn't give us number of moles, so there's no way we would have used this, and density is not in this formula. So you see the way we proved it down to this place. So there are other gas laws equation or question that we have taken in videos below. So all you have to do, subscribe, so that anytime you see video like this or I upload video like this, you get a notification sharp time no day. So this is the second video I'm analyzing, second question rather, I'm analyzing in this video. So do well to share. So please, you need to make a video for me. If I come your house, is that if you watch the video, just share it so that others can gain. Nobody you want to gain. The aim is to not forget that. So thank you for watching. Of course, I have other questions I want to analyze this week. For those of us that are writing post UTME in Uniben, of course, I'll be doing a brief analysis of some certain questions. I don't like my videos to be very, very long. Nobody get patient. Make sharp, available, find somebody, something sharp time, not day. So as you watch the video, do well to share. Thank you very much. I'll see you in another video.